Welcome to the deep dive. Today we're tackling a challenge many of you involved in industrial operations will instantly recognize: the headache of flange leaks.
Oh, yeah.
We're talking about those really frustrating moments when a connection in a critical system just refuses to seal. It leads to wasted time, potential hazards, and, well, money down the drain.
That's right. For anyone who's worked with pressurized systems, yeah, discovering a flange leak brings with it a unique kind of dread. It's definitely more than a minor annoyance.
Much more.
It can bring entire operations to a standstill and pose serious safety risks, too.
Absolutely. So the core question we're really drilling down on today is this: how can damaged flange sealing surfaces be effectively repaired right there, on site, minimizing those major disruptions? And we're focusing on the kind of damage that goes beyond just a superficial scratch, things like, dense erosion or corrosion deeper than about 0.3 millimeters.
And the key concept here really is on-site, because traditionally, damage like that could mean a really lengthy process. Complete disassembly, sending the bulky flange off to a specialized workshop, and then you're just waiting for its return and reinstallation. That timeline can have a massive impact.
Which leads us straight to our mission for this deep dive: to understand exactly how portable flange facers provide a rapid and effective solution for these very problems, keeping those crucial systems sealed and operational.
Yeah.
Now, when you hear portable machine tool, you might picture something, I don't know, cumbersome and maybe not that precise, but that's really not the case here, is it?
Not at all. Let's get straight to the heart of it. What is a flange facer? Imagine a specialized, quite compact machine tool.
Right.
Its primary job is to attach directly onto a flange, and then, well, in a way similar to a lathe you'd find in a machine shop, it precisely remachines the flange's sealing surface.
Okay, so it's essentially bringing that machine shop precision directly to the problem flange. And the major advantage, I guess, is restoring that critical flatness and the necessary surface finish without ever detaching the flange from the system itself. That sounds like a huge leap forward right there.
It truly is.
Yeah.
So how do these ingenious machines actually operate? Okay, let's unpack this a bit.
Yeah, let's get into the mechanics.
At its core, a flange facer is, like you said, a specialized but compact lathe.
Yeah.
But it's designed not for round parts, but specifically for those flat surfaces where the seals are absolutely critical.
Makes sense. Now, how does it actually grip onto the flange? Because I'd imagine there's quite a variety of flange designs out there.
Exactly. There are a couple of primary ways these machines mount. One very common method is the internal mount, often just called ID mount.
ID mount.
Yeah. This involves an expanding clamping mechanism that fits right inside the bore of the flange.
Inside the hole. So.
It's widely used and often a very straightforward way to get secure and, importantly, centered mounting.
Okay, that seems practical for a lot of standard flange types. What's the other main approach then?
The other main method is the external mount, or OD mount, outside diameter. So in this scenario, the machine uses clamps that grip the outer edge of the flange.
Ah, okay.
This is particularly useful when the central bore of the flange needs to stay clear, maybe for access or something, or sometimes when you're dealing with really large flanges where an internal mount might not have enough stability or just be impractical.
Interesting. So, okay, once the machine is firmly locked in place, what does the actual cutting? How does it remove the material?
The core of the operation relies on a rotating tool head. This head securely holds one or sometimes more cutting tool bits.
Right.
As this head spins, these bits sweep across the face of the flange, precisely removing the damaged material layer. And typically you use specialized replaceable insert bits. These are chosen based on the specific material of the flange itself, whether it's common carbon steel or maybe stainless steel for corrosion resistance, or even lighter stuff like aluminum alloys.
So it's not just like grinding it down, it's a controlled, precise cutting action, much like you'd see in a proper machine shop setup.
Exactly, precision cutting.
Now, you mentioned achieving the correct surface finish. That sounds critical. How does the machine manage that aspect?
That's where the feed mechanism is absolutely key. To get the required surface finish for a reliable seal, and this can range from very smooth to a specific textured pattern, like a gramophone record finish, depending on the gasket.
Ah, right. Those spiral grooves you sometimes see.
Precisely. The cutting tool bit needs to move across the flange face in a highly controlled way. This movement can be radial, so the tool moves inwards or outwards, along the radius.
Tracing that spiral.
Yeah, creating that pattern. And there's also axial movement, where the tool moves perpendicular to the flange face.
Okay.
That's particularly important for creating or repairing grooves or working on features like raised hubs.
Got it.
The crucial point is that the speed the cutting tool advances is meticulously controlled. It can be manual, by a skilled operator, or through integrated powered systems, usually pneumatic or hydraulic.
Pneumatic or hydraulic power.
Right. This ensures consistent results and that the final surface finish meets the required spec, often measured in raw values.
Ah, that's the roughness average.
Exactly. It tells you how smooth or rust the surface is. And generally, lower feed rates give you finer, smoother finishes. It's critical for the gasket to create that tight seal.
It sounds like even though these are portable field-use tools, they're engineered for a surprising level of accuracy.
Absolutely. These machines are built tough. They have a robust, rigid structure. They use high-precision bearings and feature carefully calibrated feed systems. This lets them achieve very tight tolerances. We're talking about both the overall flatness of the face and that crucial surface finish.
And these tolerances meet industry standards.
Oh, yes. It's not uncommon for the results to meet stringent standards like ASME B16.5.
Right.
That's paramount for guaranteeing a reliable, leak-free seal once you bolt it all back together.
Makes sense.
And of course, a critical step after any machining like this is thorough cleaning. Get rid of all the swarf, the little metal chips and debris.
Right. Can't leave that behind.
The overarching goal always is to remove the absolute minimum amount of material necessary, just enough to restore that perfect sealing surface. You don't want to take off too much and compromise the flange's strength.
Right. Precision without being excessive. Now, we've talked a lot about flat facing, which I guess is the most common job.
Probably, yes.
But what other kinds of machining tasks can these portable powerhouses handle out there in the field? Because flanges aren't always just simple flat surfaces, are they?
That's an excellent point. The capabilities go well beyond just simple resurfacing. What's really remarkable is their versatility.
Okay.
For instance, they can be used to machine or repair ring-type joint grooves, RTJ grooves.
RTJ, those are for metal gaskets, right? High pressure stuff.
Exactly. It's a precisely machined groove where a special metal ring sits. When you tighten the flange, that ring gets compressed, creating an incredibly tight metal-on-metal seal. Perfect for very high pressures.
And these machines can cut those precisely.
Yes, they have to be cut to very specific dimensions and tolerances. They can also handle creating or repairing O-ring grooves for, rubber or elastomeric seals, and even the specialized profiles needed for lens ring seats. That's another type of sealing solution for extreme pressure environments.
Okay, so not just flat faces, but intricate grooves, too. That's impressive versatility.
Precisely. And it doesn't stop there. Flange facers are also invaluable for tube sheet repair and heat exchangers.
Heat exchangers, that's where all the tubes meet a plate.
Right, ensuring perfect gasket seals on those tube sheets. And also divider bars within the exchanger. They can even resurface things like pump bases or housings.
Why would you need to do that?
To guarantee a perfectly flat mounting surface. That's critical for preventing vibration and ensuring proper alignment, especially with rotating equipment like pumps.
Ah, makes sense. Alignment is key.
Absolutely. Another vital application is weld preparation, creating accurate edge preps like bevels or counterbores on flanges or pipe ends before welding.
For a stronger weld.
Exactly. Leads to stronger, more reliable welds. And in some setups, depending on the machine and attachments, they could even do spot facing around bolt holes.
Spot facing.
Creating a flat, perpendicular surface right under the bolt head or nut ensures even clamping pressure when you tighten the bolts.
Oh, okay. Prevents uneven stress.
Correct. And some can even handle limited drilling and milling tasks, too.
Wow, that's a much broader range of capabilities than I first thought. So these are far from being just single-purpose tools.
Exactly right. This impressive versatility comes from a few key design aspects. Interchangeable mounting systems for different flange types and sizes, modular tool heads for various cutting bits and profiles, and those highly precise feed controls we talked about earlier. Got it. They combine to make them incredibly valuable for comprehensive on-site flange maintenance and repair.
So it's clear these machines are incredibly capable. But where are they really indispensable? Which specific industries rely on them most? Is it a niche thing?
Actually, quite the opposite. While it might sound like a very specific tool, portable flange facers are essential across a surprisingly diverse and critical range of industries.
Such as?
Well, think about the entire oil and gas sector, upstream exploration and production, downstream refining, and all along those vast pipeline networks.
Okay, oil and gas makes sense. High pressures, critical infrastructure.
Definitely. Then there's power generation, all types. Traditional fossil fuel plants, nuclear power facilities, even renewables where you have critical steam and water systems.
Right, power plants have huge amounts of piping.
Huge amounts. Petrochemical and chemical plants are also major users, maintaining integrity in reactors, columns, tanks, complex piping. It's paramount there, especially with aggressive chemicals and high temps.
Safety is huge there.
Absolutely. Then you have shipbuilding and repair. Think about the vast, intricate piping systems on ships. They need regular maintenance, often in confined spaces during dry dock.
Ah, doing it on-site in dry dock saves pulling massive pipes out.
Exactly. Even industries like pharmaceutical production and food processing rely on them.
Really? Why there?
For maintaining those sanitary, perfectly sealed connections required for product quality and safety. Think sterile or hygienic processes. Any tiny leak or crevice is a problem.
Okay, that makes sense. Maintaining purity.
You'll also find them crucial in mining operations, heavy construction projects with lots of infrastructure piping, and even in the pulp and paper industry.
So pretty much anywhere with significant pipework and flanged connections under pressure.
Essentially, yes. Anywhere a leak in a pressurized system could lead to big problems. Safety hazards, environmental damage, or just huge financial losses from downtime. These machines are likely an indispensable tool.
So it sounds like the common thread is high stakes, high cost of failure.
Precisely. And if you look at the bigger picture, the unifying factor across all these different sectors is that potentially enormous cost of failure leaks, downtime, contamination. Add to that the inherent difficulty and cost of removing and transporting often very large, very heavy components.
Yeah, logistics must be a nightmare sometimes.
And then there's stringent regulatory compliance demanding leak-free operation, plus the fundamental need for repairs that are both precise and durable. All these factors really underscore why this technology is so critical.
That really paints the picture.
Yeah.
Now, we've touched on some advantages of doing repairs on site, but let's really dig into why portable flange facers are so suited for this field work rather than always going to a workshop. What are the killer benefits?
Well, the most significant advantage, and honestly, it's often a game changer, is that portability just completely eliminates the huge downtime and costs associated with disassembly.
Right.
The often complex and expensive transport of the flange, these things can be incredibly heavy and awkward.
I can imagine.
And then the potentially long wait time for the workshop repair itself.
So time is the big one.
Time is huge. These machines are engineered to be relatively compact and designed for quick setup. They offer versatility for various tasks, as we've discussed, and they deliver high accuracy, essentially bringing precision machining right to the problem spot.
So let's break down those advantages. Downtime reduction that has to be massive.
Absolutely massive. Think about the whole sequence without on-site machining, dismantling systems, getting heavy lifting gear, transport, workshop queues, then reassembly.
Days, weeks.
Easily, days, often weeks. With on-site facing, the repair can frequently be done within a single work shift. Maybe slightly longer for complex jobs, but still dramatically less time.
Wow.
That means a massive reduction in lost production time. I mean, I've heard of critical repairs done during short, planned maintenance windows that saved companies enormous sums compared to a prolonged shutdown.
That kind of time saving must also mean huge cost savings, too.
Undeniably. You're avoiding all those costs. Cranes, specialized transport, workshop labor charges, and the massive financial hit of an extended plant shutdown.
Yeah.
The investment in either portable machining services or even buying the equipment can often pay for itself incredibly quickly just through these avoided costs.
And the logistics side, moving massive components must be complex and risky.
Precisely. You eliminate all that intricate planning, and importantly, you mitigate the safety risks involved in lifting and maneuvering large, heavy parts.
Safer for the crew.
Much safer. These portable machines are designed to be transported and set up by trained technicians, even in tough spots like offshore platforms or remote pipelines. Some are even self-contained units.
Minimizing support needed. That rapid response capability also sounds really valuable. Spot a leak during inspection, fix it fast.
Exactly. It allows for a much quicker reaction to unexpected leaks or damage found during maintenance. You can prevent a minor issue from escalating into a major headache with much bigger consequences.
And you're getting that crucial precision right there on the spot, ensuring a reliable seal afterwards.
Yes, that's key. Modern portable facers deliver workshop-level accuracy right there in the field. They meet those demanding industry standards for flatness and surface finish.
So you're not compromising on quality?
Not at all. You get a reliable, durable seal every time the connection is remade.
And the versatility, we talked about one machine doing multiple jobs.
Correct. One machine can often handle a significant range of flange sizes, from small to very large, and do facing, grooving, beveling. It makes it an incredibly adaptable tool for maintenance teams.
Flexible.
Very. And finally, like you hinted at with safety, by not needing to lift and move those huge components, you're inherently making the job site safer, less risk.
So it really sounds like portable flange facers are, I don't know, democratizing precision machining, bringing that vital capability right where it's needed,
That's a great way to put it.
in a way that's faster, safer, more cost-effective, and ultimately just more efficient.
That's a perfect summary. They really offer a critical solution for maintaining the integrity of flanged connections across just a huge number of demanding industrial environments.
Well, this has been a truly insightful deep dive into the world of portable flange facers. It's really remarkable to see how such a specialized piece of kit can have such a broad and significant impact,
Yeah, across so many critical industries.
playing that vital role in minimizing downtime, cutting costs, and ultimately ensuring the integrity of the essential systems we all rely on, really every single day.
What's particularly fascinating, I think, is how this specific technology solves such a fundamental and widespread challenge.
Yeah.
It just cuts across so many different fields.
Absolutely. So, as you're reflecting on this, maybe consider the potential impact of understanding or perhaps even implementing on-site machining solutions for the reliability and efficiency of any industrial systems you might encounter or manage.
Mm.
It really makes you wonder, what other seemingly complex industrial challenges might have equally innovative on-site solutions just waiting out there, ready to be discovered, or maybe just more widely adopted? Thanks for joining us for this deep dive.